Today's lesson we're going to be solving absolute value equations and inequalities. For the do now, I want you guys to find all the possible values, stress all their possible values of x in each equation. And if you guys want to do 1, 2, 3, 4, 5, then check all your answers, that's fine. But say you want to do 1, pause, check and see if 1's correct, then do 2, check and see 2's correct, then do 3, you can do that also. So pause the video right now and replay it once you are done. So number 1, the absolute value of x is equal to 7. In order to solve this equation, we have to understand absolute value. So absolute value, let's say like absolute value 5. The absolute value of 5 is just 5. And the absolute value of negative 5 is the same thing. It's just 5. Because absolute value turns whatever value is inside to be positive. That is because absolute value is the distance away from 0. And distance is always positive. It doesn't matter what direction you're walking in. You can walk 5 feet west or 5 feet east, 5 feet north, 5 feet south. It's always positive 5 feet. So let's take a look at number 1. It says the absolute value of x is equal to 7. So I know that the absolute value of 7 is going to equal 7. But I also know the absolute value of negative 7 is going to equal 7. Therefore, x can be either negative 7 or it could also be 7 and make the equation true. So my solutions are negative 7 and 7. Number 2, we want to get the absolute value by itself. Look at number 1, the equation number 1, the absolute value is all by itself. But in number 2, it's not by itself yet. What can we do to get the absolute value all by itself? Well, we can just subtract 2 on both sides. That cancels out the plus 2 on the left, and we're just left with absolute value of x is equal to 7 minus 2, which is 5. And now we have the same kind of equation as we did in number 1. We know that the absolute value of 5 is equal to 5, so x would equal 5. But we also know the absolute value of negative 5 is also equal to positive 5. So my solutions will be 5 or negative 5. Looking at number 3. Well, number 3, the absolute value is all by itself. So when we look inside the absolute value, I know that x minus 2, in this case the x also has a minus 2 with it inside the absolute value, can either equal positive 7, because the absolute value of 7, positive 7 will be 7, or my other value that x minus 2 can be is negative 7, because I know the absolute value of negative 7 is also equal to 7. So I'm going to set those two equations and I'm going to solve from there. So the top one, I'm just going to add 2 on both sides. That gets my x by itself, so that would be x equals 9. And we do the same thing for that second equation. Add 2 on both sides. X equals negative 5. So my answers would be x equals 9 and x equals negative 5. You can always check that. So come over here and check. You want to plug your both answers in for x one at a time. So I'm going to plug in my first solution, which I got 9 minus 2 is equal to 7. I get the absolute value of 7 is equal to 7. Yeah, 7 equals 7. That's good. That checks. And do the same thing with negative 5. Whenever you plug in a negative number, always use parentheses. It's going to help you make a lot less mistakes. So negative 5 minus 2, absolute value is equal to 7. I end up getting the absolute value of negative 7 is equal to 7, while the absolute value of negative 7 is 7. So that checks out. So they're both solutions. Let's look at number 4. The absolute value is not by itself yet. So I'm going to subtract 10 on both sides to get the absolute value by itself. I now have the absolute value of x is equal to negative 3. Like we were saying before, you can never have an absolute value that's negative. Absolute value is always positive, so you could say, I don't know if anyone said, Oh, x would equal negative 3. Check it. Absolute value of negative 3 is 3, not negative 3, because it makes it positive. So, in this case, our solution is we have no solutions. We can't plug in a value for x that would make the absolute value of x equal to a negative number, which in this case is negative 3. So we would have no solution. You can say that, or you could also say no solutions. And the last one, number 5. I want to get the absolute value alone. It's not alone yet on the left. I need to divide by 2 on both sides of the equation. They cancel out the 2's on the left. So I get the absolute value of x is equal to 7 over 2. I'm just going to make that 3.5 because 7 over 2 is the same as 7 divided by 2, which is 3.5. So I know x can equal 3.5, but x could also equal negative 3.5. So that would be both our solutions. What should I know by the end of the day? Well, I can solve absolute value equations with variables on one side or both sides of the equation. I can explain the rationale behind the process of solving an absolute value equation. I can assess whether an absolute value equation has no solutions. I can solve absolute value inequalities. I can explain the rationale behind the process of solving an absolute value inequality. And lastly, I can assess whether an absolute value inequality has no solutions or has a solution set of all real numbers. Let's go to the next page. Looking at number 1, it says solve each of the following equations. Absolute value of 3x minus 1 is equal to 28. So first step we want to do is get the absolute value by itself. It is by itself. We just have the absolute value of 3x minus 1 on the left side, so we're good there. But we know we want the inside the absolute value to either be positive 28, because we know the absolute value of positive 28 is 28, but we also know it could potentially be negative. It could be negative, the absolute value of negative 28, because we know that will also equal 28. So that is the logic we want to use for solving this equation. So I know that inside the absolute value, that 3x minus 1, I know that could represent positive 28. Or I also know inside the absolute value, if it's the absolute value of negative 28, that's also going to turn out to be positive 28. So I know 3x minus 1 could also equal negative 28. So we write two different equations, one equal to the positive and one equal to the negative value on the opposite side of the equation. So from here, we have our two equations. We just want to solve one at a time. So I'm going to take the one on the left. I'm going to add 1 on both sides. I get 3x equals 29. Divide by 3 on both sides. You should get x equal to 29 over 3. And the second equation we wrote, 3x minus 1 equals negative 28. I'm going to add 1 on both sides here. You have 3x equals negative 27. Divide by 3 to get x by itself. And x is equal to negative 9. Now, before you go circling those answers, let's check just to make sure we're correct. So I'm going to come over here and write check. And so what we're going to do is we're going to plug in each of our answers separately in for x to make sure we get, when we plug it in, 28. So I'm going to check the first one. That'll be 3 times my first x I found was 29 over 3 minus 1 at close the absolute value equals 28. So I multiply. You can put that 3 over 1 if it's easier to think of. So these 3's cross cancel to 1 and 1. So we're left with 29 minus 1 on the inside, which is positive 28. And the absolute value of 28 is equal to 28. That checks. We're good. And the second one I want to check is our second solution, which is negative 9 minus 1 equals 28. 3 times negative 9 is negative 27 minus 1 negative 28. The absolute value of negative 28 equals 28. We know the absolute value of negative 28 is 28. So that checks. They are both solutions to our equation. And I also want to show you guys how to check that on your calculator, because it can save some time checking on your calculator. So let's go to the calculator. So in your calculator, what we're going to do is we're just going to plug in each of the values in for x. So in order to get to the absolute value, you need to press math, go over to num. Abs is right there. It's short for absolute value. You get the absolute value bars. You might, if you have the older edition of the calculator, you might get abs with parentheses. Just make sure to close the parentheses out at the end. So this would be 3. And I'm going to check 29 over 3 first, times. I'm going to write 29 over 3 as a fraction. So that would be, press alpha, y equals, and then choice 1 is n over d, which stands for numerator over denominator. That gives you the fraction notation. You can just write 29 over 3 there. Makes it nice and easy, minus 1. And then when you press enter here, what should you get if this is a solution? You should get 28. So that's, you can check it like that, and you can also check the next one. Our other solution, which was 3 times, our solution was negative 9 times negative 9, minus 1. This is where you have to close out the parenthesis if you have the older edition of the calculator. Press enter. We get 28, so they both check. So that's how you would check using your calculator. Number 2, we want a very similar process, do a very similar process. We have to get the absolute value alone by itself on one side first. So in order to do that, I'm going to first add 10 on both sides. So plus 10, plus 10. That 10 cancels. We're left with negative 6 times the absolute value of x minus 15 is equal to 12. Absolute value is still not by itself, so we have to divide by negative 6 on both sides. And we get the absolute value of x minus 15 is equal to negative 2. So from here, we want to do a very similar thing we did to number 1. We would set x minus 15 equal to negative 2, and x minus 15 equal to positive 2. So you set up into the two equations, one equaling the positive, one equaling the negative value on the opposite side of the equation, and solve for there. Add 15 on both sides, add 15 on both sides of the equations. You get x equal to 13, and x is equal to 17. Now make sure you check before you go circling those answers. So if I come over here, I check. You can do this in the calculator also if you would like. So I'm going to check 13 first. That'll be negative 6 times 13 minus 15 minus 10 equals 2. I end up getting negative 6 times the absolute value of 2 minus 10 equals 2. That would be negative 12 minus 10 equals 2. Negative 12 minus 10 is negative 22, which is not equal to 2. So we got to change all these signs to not equal to. So this does not work. We actually reject 13. So 13 is a rejection. That is what we call an extraneous solution. So an extraneous solution, it's a solution to a transformed version of an equation that is not a true solution to the original equation. And let me explain more what that means. So in order to solve our equation in number 2, we have to first add 10 to both sides. That's we're transforming the equation. And then we divide by 6, which is another transformation to get this more simplified equation. Now, sometimes when you get a solution to a more simplified equation, it's not an actual solution to the original equation when you plug it into the original equation. So that's why you always have to make sure you check absolute value equations. So let's check 17 also. We got to check our other solution. That'll be negative 6 times the absolute value of 17 minus 15 minus 10 is equal to 2. We're going to end up getting the same thing, negative 22 is equal to 2, but that's not true. So this is not a solution. It's an extraneous solution. Therefore, we have no solutions. So this would be a case where we have no solutions. And some of you guys might have seen this right off the bat. You might not always see it right off the bat. But say you just stopped right here. And you said, well, I know that an absolute value can't equal a negative number. So I'm just going to cut off right here and say, no solution. You could do that too. But you might not always see that. So you might keep on solving. Just make sure you check, because then you will see both my answers are not actual answers. So there is no solution. That's why it's very important to always check absolute value equations. So let's do the last one on this page. When I look at this one looks a little different than the ones we've done before. How is this one different than the ones we've done before? Well, when I take a look at it, there's an x on the left, there's a variable on the left of the equation, and there's also a variable on the right side of the equation. So this is a little bit different. We're going to still do the same thing. So we know that the inside, x minus 2, can equal the positive version on the left, or on the right, excuse me, on the opposite side. So that would be x minus 2 is equal to the positive version, which is just negative 3x plus 18, what's on the right side. Or it could also equal the negative version of what's on the right. So that would be x minus 2 is equal to negative 3x plus 18. So we're going to multiply that right side of the equation by a negative 1. What that essentially does, it just flips the signs of each term on the right side. So that would be negative 1 times negative 3x would be positive 3x, and then negative 1 times positive 18 minus 18. So now we would want to solve both equations. So here I'm going to get the x on one side. I always try and keep my x positive. It just helps from making mistakes. So that'll be 4x minus 2 is equal to 18. I'm going to add 2 on both sides. You get 4x equals 20. Divide 4 on both sides, and you get x equals to 5. Same thing over here. I'm going to subtract x. I get negative 2 equals 2x minus 18. And I'm going to add 18 on both sides. 16 equals 2x. And finally divide by 2. And we should get x equal to 8. But let's check our answers before we go circling them. One or both may not be actual solutions. It could be extraneous. So over here I'm going to check. I'm going to first check 5. So I'm going to plug that in for both x's. So that would be absolute value 5 minus 2 is equal to negative 3 times 5 plus 18. I get 3 on the left, and you also get 3 on the right. That checks. Good. Circle it. That's one answer. And let's check 8 also. So I have 8 minus 2 is equal to negative 3, and I plug in 8 there, plus 18. On the left, I get 6. On the right, I get negative 6. So this 8 does not make the original equation true. So that is a rejection, which means our only solution is x equals 5. And what would 8 be called? It would be called an extraneous solution. It's not part of the solutions, but it's just good to know the terminology. So on the next page, I just want you guys to do 1, 2, 3, and 4. Take, this is going to take some time. Take 5 to 10 minutes. Pause the video. And when you're done, play it. And I will show you the answers for 1, 2, 3, and 4. Here are the solutions to the checkpoint 1 through 4. Check out number 1. First thing you have to do is get the absolute value by itself. And then once you get the absolute value by itself, you set what's inside of the absolute value equal to the positive side of what's on the left and also the negative side. So you set up into 2 different equations. Make sure you check your work at the end. One of those could be an extraneous solution. In this case, it wasn't. Number 2, when you get the absolute value alone, you get at the very end the absolute value of x minus 15 is equal to negative 3. You can't have an absolute value equal to a negative number, so we have no solutions. Number 3, be careful. Gotta first get the absolute value by itself. But then when you check your solutions, 10 over 7 is an extraneous solution. So it's not a true solution to the original equation. So that gets crossed off, and our only solution is 18 over 5. And number 4, the last one, the equation absolute value of 3x minus 2 minus 1 equals 17 has 2 unique solutions that can be found using which 2 equations. So your first step, add 1 on both sides. So we know it's going to be 18 on both sides of the equation there, which the only one with 18 on both sides of the equation is actually D, so you could have circled it like that. But also, 3x minus 2 would equal 18, and then you got to set it equal to negative 18. But take a look at what they did in this second equation. They didn't set it equal to negative 18. They set the left side to be negative. So they said negative times negative 1 times the quantity 3x minus 2 is equal to 18. You can do that also. I just find just making the right side, multiplying the right side by negative 1 is a little bit easier for me to think of at least. So that's why that is D. So we're going to move on to absolute value inequalities on the next page. Number 1, we're going to be solving an inequality here. It says the absolute value of x is greater than 7. So solving absolute value inequalities is very similar to solving absolute value equations. Much like solving inequalities is very similar to solving equations. There's just a couple of tiny differences, just like when we are solving just equations and inequalities. So when I look at number 1, it has the absolute value of x is greater than 7. We're still going to want to split this up into 2 inequalities this time. So we know that absolute value of x is greater than 7. We know that x has to be greater than 7. But we also want to do x and then the opposite, or the negative version of that right side, which is negative 7. But think about when we are solving absolute value or any inequality. When I divide or multiply by a negative number, what do we have to do with the inequality sign? We have to flip it. So this second inequality is going to be x is less than negative 7. All the same rules apply. Actually, this is pretty much already solved for us. But what I want you guys to do is always graph it so you can see how we are going to write our solution set much easier. It's so much easier to graph one inequality than graph the other one once it's completely solved for, which in this case it is. So we have two main values, 7 and negative 7. You don't have to do a perfect number line. I'll just put 0 there. Here's 7. Here's negative 7. You can just sketch one. You don't have to write down every single number in between 7 and negative 7. So I'm going to graph first. X is greater than 7. So I put an open circle at 7. Greater than goes to the right. And then x is less than negative 7. Open circle at negative 7. Less than goes to the left. So one way to show your solution is a number line. You can also use interval notation, which would be negative infinity up until negative 7. Close parentheses, because we don't include that negative 7 in union with u, 7 to infinity. Or you can keep it in equality notation, but you want to keep the lower end to the left, so that would be x is less than negative 7, or x is greater than 7. Can't put an and there, because they're not going both between each other. If you fill out the middle part, so if we were to fill out this part, that would be an and, because both inequalities be working together. But that's not the case here. It's either less than negative 7 or greater than 7. Cannot be both less than negative 7 and greater than positive 7. So anyway, you want to say that solution in either of those three ways, completely fine. Unless the question tells you have to use one of those ways of expressing the answer. Number 2, we're going to do a very similar way. Look at our absolute value. It's all by itself. Awesome. So now I can use my two inequalities. So it'll be x minus 6 is less than or equal to 7. And my other inequality would be x minus 6. Remember, negative 7 will now go on the right side, not positive 7. We have to count for the negative. But you also flip that inequality sign. And why do we flip the inequality sign? Well, we're multiplying by negative 7 on the right, so we have to flip the sign. So from here, just continue to solve each inequality. You would end up getting x is less than or equal to 13, and then add 6 on both sides. X is greater than or equal to negative 1. So when we look at our number line, I'm going to draw my number line here. Here's negative 1. Here's 13. We include both points, so when x is less than or equal to 13, I fill in the circle. I know less than goes to the left. And x is greater than or equal, so it can equal it. We close the circle at negative 1, and that goes to the right. You see how they meet? You can fulfill both of those. So this would be an and inequality, so you can write it as negative 1 is less than or equal to x, which is less than or equal to 13. Or you can use interval notation. We would include negative 1 and 13, so you would use brackets there. And either of those ways of expressing the answer is completely correct. That last part, what makes the process of solving an absolute value inequality different from solving an absolute value equation? I want you guys to take a couple minutes here and complete sentences. Write what you think makes the solving the absolute value inequality different from solving an absolute value equation. Pause the video and play it once you're done. So there's a couple things that come to my mind. I would say we still separate the inequality into two inequalities, but when we account for the negative, we have to flip the sign. So when we account for the negative value, inside of the absolute value, we must flip the inequality sign. So that's the main difference I see when solving an absolute value inequality than solving an absolute value equation. And the other one, take a look at our answers. Our answers for the absolute value equations were just one answer. Look at like number 3 from a couple of questions ago. We just got one answer. Look at number 1. We had 2 answers, but it's just a thick set of answers. Here, for inequalities, we have intervals. So we have every number between negative 1 and 13, or every number greater than 7, or less than negative 7. So our answers here are intervals of numbers instead of specific numbers. So our answer is an interval of numbers instead of 1 or 2 specific numbers. That's what comes to my mind. Definitely that first one is the biggest difference for the process of solving absolute value equations and inequalities. So on the next page, we're going to solve some more absolute value inequalities, and that will be it for the lesson. So on the next page, just take. Actually, we'll solve number one. So looking at number one, we want to get the absolute value all by itself for number one. Is it all by itself? No, it's not. So in order to get it all by itself, we have to subtract 3 first on both sides of the inequality. So I subtract 3 on both sides of the inequality. I'm left with absolute value of x minus 6 is greater than 4. Now I do have the absolute value all by itself. So from here, I'm going to split this up into our two inequalities. So I have x minus 6 is greater than 4. And I also have x minus 6 is less than negative 4. Solve both inequalities. So I'm going to add 6 on both sides here. I get x is greater than 10. Add 6 on both sides here. I get x is less than 2. Once you get your two inequalities simplified, draw that number line. It makes it so much easier to understand the answer. So I'm going to label 10 and 2. X is greater than 10, so it's a hollow circle, and it goes to the right. And x is less than 2, hollow circle, goes to the left. This would be an OR inequality, so you could say x is less than 2 or x is greater than 10. Another way you could put the answer, instead of number line or inequality notation, you could use interval notation. So that would be from negative infinity to 2, close parentheses, in union with 10 to infinity, close parentheses. Either of these three are completely okay. Number 2, we have an absolute value inequality. We have to do the same thing we have been doing, get the absolute value alone before you write your two separate inequalities. So I'm going to add 6 on both sides. That gives me 3 times the absolute value of 2x minus 5 is less than or equal to 21. Our absolute value is still not by itself. It's getting multiplied by 3. So we have to divide by 3. And now we get 2x minus 5 is less than or equal to 21 divided by 3 is 7. Now we have our absolute value all by itself on the left side of this inequality. So now I can write my two inequalities. I have 2x minus 5 is less than or equal to 7. And I also have 2x minus 5, flip the sign, and multiply by negative 1 on the right is greater than or equal to negative 7. So I'm going to solve both these inequalities. I add to 5 on both sides. I get 2x is less than or equal to 12. Divide by 2, divide by 2. I get x is less than or equal to 6. And I do the same thing with my other inequality that I wrote. I get 2x is greater than or equal to negative 2. Divide by 2, divide by 2. X is greater than or equal to negative 1. To write my answer, I'm going to draw a number line. This helps me understand how to write the answer in interval notation or inequality notation better. So here's 6, here's negative 1. I'm going to graph one inequality at a time. So x is less than or equal to 6. I fill in circle at 6 and I go to the left because it's less than. And then x is greater than or equal to negative 1. Fill in the circle at negative 1, and this is going to the right. As you see, the number line is going to meet. You could also write this in interval notation. So that would be, we include negative 1. So it would be from negative 1 to 6. And we include 6 also. So we use brackets. Or we could use inequality notation. And this would be an and inequality because you can fulfill both inequalities at the same time. So that would be negative 1 is less than or equal to x, which is less than or equal to 6. And that would be our answer. And the last two. Number 3, oh, look at that. We have our inequality all by itself on the left side. So we don't need to go on and it simplifies anymore. But let's take a look at what it says. It says the absolute value of x minus 1 is greater than negative 6. An absolute value is always positive. So the absolute value of x minus 1 is always going to be greater than negative 6. So in this case, if you see it right off the bat, our solutions are just going to be all real numbers, because I can plug anything in for x, and no matter what, the absolute value of x minus 1 is always going to be greater than negative 6. Or you could put that in interval notation, negative infinity to infinity. Either of those are completely perfect. And just so, I'll try a couple numbers just so you guys can see. So we'll try let's try like 9 first. I'm going to plug in a random number 9. 9 minus 1, absolute value is greater than negative 6. That would be absolute value of 8 is greater than negative 6. 8's greater than negative 6. That works. Now try another random number. Let's do negative 500. So absolute value of negative 500 minus 1 is greater than negative 6. I get the absolute value of negative 501. It's greater than negative 6. 501 is greater than negative 6. That checks. So any number you plug in, any real number you plug in, it's going to be a solution to this inequality. Now, on the contrast, our next one says the absolute value of x minus 1 is less than negative 6. So it's this absolute value is all by itself on the left side, but an absolute value can never be negative. So an absolute value can never be less than 0, or in this case, it can never be less than a negative number. So therefore, we have no solution. Nothing we plug in for x will give us a number that the absolute value of x minus 1 is less than negative 6. So that's it for today. I just would like you guys to do the success criteria to make sure you are good with all the concepts we did today. And then we have the practice, classwork, and homework.